Sine, cosine, and tangent ratios, numbers for side lengths. All right, so we are starting to get into trig. That's what sine, cosine, and tangent really is the beginning of trig. So what we want to do is we need to know what our sine, cosine, and tangent ratios are. So there's a really, really easy way to remember that. So we have so, ka, toa. So it sounds funny, but it helps you remember the order. So these are the three trig functions. We have sine, cosine, tangent. So that's what S, C, and T stand for. So what this means is sine of an angle, and we're going to use theta like this, equals O is for opposite, and H is for hypotenuse. And then cosine, so that's C, equals adjacent is for A, and then H again is for hypotenuse. And then we have tangent. Remember, that's what T stands for. And then we've already said O is for opposite, A is for adjacent. So we have opposite over adjacent. And this is just, depends on the triangle you're looking at and the angle. But when you're, I'll draw one out here. So if we have this angle, here's what we're looking at. And for these trig functions to work, we need a right angle. We'll get into it later when we don't have a right angle, but for right now, we need a right angle. So we're either going to be looking at the angle on the bottom here or the angle at the top. Those are the two things. And I forgot to put angle symbols in here. These are the, so I'll label this one theta like this. So these are the notes. We should be writing these down because we need these to move forward. So if I'm looking at this angle and I'm saying opposite, and I'm going to actually change my color up here. Let's go. So all these opposites, I'm going to put in red here. And I know they're double colored. And then we have O and O. All right. So opposite means I look at the angle and I go to the side that's opposite. So this is opposite. And then I'm going to switch my color up again here. So let's go with hypotenuse. So let's look at H, and I'm going to go with orange for H for whatever reason. So hypotenuse is an orange. All right. So if I want hypotenuse, hypotenuse is always across from the 90-degree angle. Always, always, always. So this is our hypotenuse here. And then the last piece that we have is adjacent. So A and A. So we have adjacent and then adjacent. All right. So adjacent has to do with if this is opposite, we go opposite the angle, that's called opposite. Hypotenuse is always this one for the 90. So adjacent is the other side length that makes the angle. So the hypotenuse and the other one, the other side, those two make this angle. So that's the adjacent side. So if I switch over to the top, so let's redraw this triangle, kind of not terribly close, but close enough. So now I'm going to look at this angle up here. Hypotenuse doesn't change. So the hypotenuse is still across. This is the same. But now my opposite, if I'm looking at this angle, my opposite is the bottom. And if I'm looking at, or if I'm trying to find adjacent, then I want the other side that creates the angle. So I have hypotenuse and this other side here. So this is now the adjacent side. So it depends on which angle we're looking at. So the adjacent and the hypotenuse can kind of switch spots depending on the angle. Hypotenuse will always be the same. It's always across from that 90-degree angle. All right, so now that we kind of have our notes here, and hopefully your second right triangle looked a little better than mine. Mine looked a little funky here. Not sure what happened there. So now all we're going to do is write some ratios based on these notes. So if we go down, we see sine, the length of the opposite over the length of the hypotenuse. So if we want the sine of A, we need to go to angle A here, and we want opposite over hypotenuse. So we go opposite, which is 7. Hypotenuse is across from the 90, so 25. So our ratio is 7 over 25. If I want the tangent of A, I go opposite over adjacent. So I go opposite, which is 7. Adjacent is not my hypotenuse, it's the other side. So we go 24, so it's 7 over 24. So all we're doing is writing 3 fractions based on these relationships here. All right, so let's go ahead and try this out. Okay, so we want to use this same idea over here. I'm going to click my pen on. I'm going to try to match up the colors a little bit, but we'll see how that comes out. So let's do sine first. So sine of m. So remember, we're looking at this angle right here. So this is the angle we're looking at. And so sine, I want opposite, which is 24. So this is my opposite. And I'm going to go ahead and label this. And then my hypotenuse, I'm going to try to match up that orange, is always across from this 90. So this is my hypotenuse. And then my adjacent, which I did in pink here, is the other side that creates this M. So think of it like there's two rays that make an angle. One of those rays is the hypotenuse. The other one is going to connect to the 90. So it's kind of in between the angle and the 90. That's another way to think of it. So that's the adjacent. So now all I have to do is fill in my ratios here. So sine is opposite over hypotenuse. Well, I already labeled this. Opposite is 24. Hypotenuse is 25. 24 over 25. Tangent, that's opposite over adjacent. So I'm going to go opposite, 24, adjacent, 7. And then cosine, that's adjacent over hypotenuse. And again, I'm just coming over here and referencing this. So adjacent over hypotenuse, that's 7 over 25. Whoop, didn't put the bottom on there for some reason, over 25. All right, so all I'm doing, once I have this labeled for the one, as long as I'm using the same angle, makes it really easy. Now, if they ask you for different angles, you do need to pay attention to that. But for now, I think they're going to just ask you for one angle at a time. So check, and we're going to go next. Clear. Okay, so let's go ahead and label this. So we'll go with, so which angle are they asking us about? So they're asking about angle A. So I'm going to mark this angle. This is the angle A that they're asking about. So let's go mark all of our sides. So we have opposite. Then we have hypotenuse. So we go to the 90 and go across from that. Hypotenuse. And then we have, in pink, adjacent. So remember, it's between the angle and the 90, or it's the other side that creates this angle other than the hypotenuse. We have adjacent here. All right, so now we have all of these, and I'm just going to click fraction on all of these too to get them filled in. So I'm just ready to go. All right, so tangent. So I'm going to go back over here to my trigonomic functions. I have opposite over adjacent. So opposite is 3, adjacent is 4. Sine is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, so I have 4 over 5. And again, the SOHCAHTOA does make it quite a bit easier to remember. You don't have to necessarily remember this right off the top of your head. If you can remember this little silly SOHCAHTOA, then you know right away S is sine opposite hypotenuse. Cosine is A and H, which is adjacent to hypotenuse. It just helps you remember really quickly without having to write out each trigonomic function which one, which two sides relate to those functions. All right, we have one more here. Clear this out, and which angle are they looking for? So they're looking for angle M. I'm going to mark angle M here. We're going to go through and we're going to get this marked out. So red, because that's our opposite. So opposite. And then hypotenuse. So we're going to go 90 and across from there. So here's our hypotenuse. And then we have our adjacent, because it's between the angle and the 90. So that's kind of, it's actually an easier way to think of it. It's the angle between, or it's the side between the angle and the 90. Okay, so now all we have to do is fill out our functions here, our ratios. So the cosine of M, cosine is adjacent over hypotenuse. So we have 9 over 41. Tangent is opposite over adjacent. I have 40 over 9. And then sine is opposite over hypotenuse. So 40 over 41. All right, so it does make it much easier too if you go through and you fill out this little label.